This is a blue box that physically I've had around for quite a while. It's a replica of the Esquire Blue Box and has the same type of buttons and physical layout of the blue box that was featured on the cover of the 1971 October Esquire article. And it wasn't the Steve Wozniak or Steve Jobs blue box, but it was one that was made for the mob and was used as kind of a illustration within the story. And I always kind of liked the look of it. Supposedly, the original had a thermite explosive inside that could be detonated, so evidence could be burned if you were busted, but I'm suspicious about that one. Anyway, what makes this one special is that a guy named David Griffith took a concept I had back in 2007 of making a blue box based on a PIC 12F683, and which I did, and made available on my ProjectMF.org site as a way of dialing into my server that supports blue box dialing and kind of emulates some aspects of the old network. So I made that available with Phil Lapsley of Exploding the Phone. Here's that version. Here's the one I made using that circuit. And it works okay, but it was written in a programming language called PicBASIC Pro. And the problem with PicBASIC Pro is that the tones sound terrible. There was a tone command that had the capability of producing two tones simultaneously as long as you used a 20 megahertz oscillator with the PIC. And I did that, and it did make, recognizable tones, but the 2600 just sounded terrible. And I didn't know exactly why. I played with filters and everything, but I could never get it to sound quite right. A better approach would have been to start from scratch in assembly or C and actually write a routine that generated a pseudo sine wave and combined digitally the two tones needed to make the MF and the other tones for the blue box. So anyway, this one had a couple of modes, but was never really that satisfied with it. I went on to make an Arduino blue box that had 12 different tone modes in it and everything else, but always wanted to try to get it into the same form factor. Well, Dave Griffith did that, so I had an extra housing, and he emulated pretty much a lot of the functions of my old box, but added a bunch of really good new stuff, and in the process made it sound really, really good. So I'm really happy with what he did. He's not only got MF, but he's got Dtmf tones. He's got the old 2600 dial pulse that sends bursts of 2600 as though you were dialing a phone. This is the method that Joe Ingressia, aka Joy Bubbles, and some other phreaks used early on with certain types of early pre-MF trunks to dial into the system. We'll demonstrate that in a bit. He also has the red box tones, both the US and Canadian versions as well as the UK version that was capable back in the day of fooling the ACTS coin collection mechanism at the phone company and allow you to make free coin phone calls, which has stopped working, of course, sadly, with the demise of the payphone. But it's still kind of a cool historical mode to put in there. He also has green box tones, which allowed a blue box user to actually take control of somebody calling them on a payphone and cause the coins to be returned to the person who was making the call, just as an operator would do. And there were some other tricks it could do, like collect the coins, which wasn't very nice. It could also put the phone into various modes that allowed the operator to listen to the tones to figure out how much deposits were being made by the user. So anyway, that's all supported in here. Very, very cool. He's got the original memory structure that I have, and it all kind of works like my code, except it's better, much, much better. So hats off to Dave. Kudos, man. This is really awesome. So I put it into this same enclosure that I used before. It, again, emulates the Esquire box. It's got the button for 2600 on the top. Your digit buttons and your KP and star or pound and star are on the front. There is kind of a clunky toggle switch on the side for power, which I don't know if the original Esquire box did, but it was kind of necessary. Finally, I put a jack on the back to plug in this external 150 ohm earpiece. That's from an old 500 Western Electric set, telephone set from the earpiece, which really is the most efficient in terms of audio output for sound power input. Sounds very good. It's got very low distortion. I do have, though, inside a very small speaker that I picked up when I was visiting Tokyo. That's where I, in fact, got this panel and this box. And one of the electronic shops had a couple of small speakers that looked like they'd be ideal for this project, so I picked up a few. And I have it in here. The audio is quite low, but it's sufficient to fool around with the box. But for serious use with ProjectMF, you really want to plug in the earpiece on the back. So we'll do that, and we'll turn it on. And it gives a very low tone, a little hard to hear. In fact, you can't hear it, but I think it's a 400 hertz tone, just as an indication that it's on. But once it's on, the volume is quite good. Here's 2600. And then the MF tones. Very cool. Second mode is Dtmf. You can temporarily select that by holding down the second button while powering on. Just normal touch tone, Dtmf touch tone. Third mode is the red box tones. That was the tone for nickel, dime, quarter. And the Canadian version, single tone. And the UK version. Same tone, different lengths. I'm not sure what coin denominations those actually represented. The fourth mode is the green box. There was a little chip of 2600 that was needed to prime the line when the operator wanted to initiate a coin return function, so that's included here. I'm not sure what the bottom 6 are. I'll have to go back over my green box documentation and see what those represent, but they appear to be 2 tones back to back. I don't recall those being a valid combination for green box, but they are here and they sound good. All these tones have very low distortion. They sound absolutely great. And the last one, which I really like, is the 2600 dial pulse. There's one guy I know of who's got an actual system that responds to this stuff still, a private system. And so this is kind of fun to play with. But for every button that you press, it sends a like number of dial pulses encoded as bursts of 2600. So 1 sends 1, 2 sends 2, 3, 3, 4 sends 4, and so on. Very, very cool. Now the neat thing about this box is when you turn it on, it remembers the first, I think, 40 key presses and allows you to store them into a memory on the box. There are 12 memories, one for each key. So for example, right now I'm going to go into the mode 5, which is the dial pulse mode. And I want to record something. So I'll turn it off, go into that mode. Do it again. That was invalid. Okay, we're in dial pulse mode. Now we're going to record a sequence. We'll just do a phone number. And now I want to save that to memory 1, so I'll just press and hold the first button. And now it's saved. Now to go into playback mode, we'll press and hold the 2600 button. Now I can play it back by pressing 1. Very cool. Now we'll turn it off, go back into the default MF mode. We'll play 2600 and just a test number. Key pulse. And now we'll save that to memory too. Go into playback mode. And we have our dial pulse playback in memory 1 still. Let that play through. But in memory 2 now we should have our 2600 and then MF or multi-frequency sequence. That playback rate is supported at 2 different speeds, and that can be set using the star and pound key in a special key power-up sequence. There's a function on the box to change the default startup modes, and several of the modes can be altered and then stored back into the EEPROM. Now, as I mentioned before, you can change the mode that the box powers up and just by holding the button associated with the desired mode and then turning it on. So for example, holding down 5 and powering up the box puts it in the dial pulse mode, but the default, if I power cycle, is still MF. So if I want to change that default, what I do is press and hold the 2600 button, power up, I get a long beep, and now I can press buttons 1 through 5 to indicate the default power up mode I want to be active. In this case, we'll pick the green box mode. And the high to low beep indicates it's been stored to double EEPROM. And it leaves me in that mode, and I can just continue as normal. Difference is now if I turn off the power and power back up, I'm in green box mode. To switch back to a different mode, just press the desired mode. Now I'm back in MF power up mode. Another mode that can be changed in a similar fashion is the MF and Dtmf tone duration, which speeds up or slows down manual and memory dialing. Memory dialing spacing becomes much shorter when you're in the short mode, which is more consistent with the way the automatic telco equipment used to handle it. Let me demonstrate that. So right now, if I power up, go into memory mode, and play back our MF sequence, I'm in the fast mode, which plays back those sequences quickly with fairly short tone durations. But I want to default to a longer mode. I hold the 2600 button down again and power up at the same time, and then press the star button, which now puts me into long duration tone mode. And now the manual tones are longer. It's a little hard to hear, but they are. But if I go into memory mode, it becomes quite obvious when I play back an MF or a Dtmf sequence. Then to change your power up default back into short mode, we press the pound button, and now we're back into default short mode. Anyway, that's kind of the basic function. So very, very cool. Works great on ProjectMF and is a very, very nice enhancement to the original PIC code with lots of good improvements, keeping the best features of the Arduino Blue Box I put together and implemented in a way that emulates my old box but really takes it to a new level. So Dave, hats off to you. I'll have a little appendix on this video that shows the internals of how I built this up. Okay, back again. I've got the screws off on the front panel. Just want to show the internals of this box. Bunch of wires kind of crammed down on the inside of it. I don't know how well that's visible, but what you can see is the back of the push buttons here. And you can see that I've got a series of resistors, 1K resistors, that are wired point to point across one side of each of the switches. And the way that the microcontroller, that little 8-pin ATTINY85 DIP, determines which button you've pressed is by measuring the resistance with the analog to digital converter on the board. And whenever you press it, a unique voltage is presented to one pin on that ATTINY85. And those resistors make sure that every button has a unique voltage level that can be detected. So that allows all the buttons to be, including the 2600, to be decoded with by using a single pin without a lot of complicated scanning routines. And it works great. And wiring it point to point on the back of these buttons really helps keep the board simple and keep everything compact. Well, I've got this arranged such that the board can be removed, and you can take a look at how I've done it. So we've got the keypad, we've got the circuit board, and inside the box we've got the 2600 switch, a power switch, and the small speaker. And the jack, I don't know if you can see that, but on the back of the box, the connections to the jack. On the circuit board, I'm using a two 3-volt lithium cells wired in series to power the board. I originally ran this through a diode to drop the voltage by 7/10, thinking it would be too high. But what I found is that the board draws almost 20 milliamps of current, which is really, really high. Part of that is because it's being run at 20 megahertz. And at that high speed, which is really at the limits of what the ATTiny can run at, the current consumption does go up quite a bit. This little blue blob here is a ceramic resonator that operates at 20 megahertz. Dave recommended a crystal and a couple of capacitors, but the resonator has a little less accuracy, but I find this one's pretty good. And the tones are quite accurate within a few hertz. And it has the loading capacitors built into it, so it reduces the parts count a bit. Here's the ATTiny85 that's socketed. It's got an electrolytic capacitor to smooth out the voltage. The input from all of the resistors on the back of the keypad go to one pin. I think it's pin 7 here. There's a couple auxiliary 1Ks to support the 2600 button. There is an output low-pass filter here, so the audio output is pulse width modulated, and it requires a low-pass filter to filter out the sampling frequency that's used to generate the tones. So there's 2 capacitors and 2 resistors, 150 ohm, 250 ohm resistors, 2.33 microfarad bypass capacitors, and a ladder configuration that allows only the lower frequencies to get through and filters out the buzzing that would be produced if the clock frequency were allowed to come through. Those are coupled then by this orange audio output capacitor, and that removes the DC component from the audio output, which would otherwise cause distortion on the speaker and eventually could even demagnetize the earpiece or the speaker that you were using, because the diaphragm would be biased in the direction of the positive voltage. So that takes that off and gives you a nice clean AC waveform. We've got the switch, nothing too amazing there, and that little tiny speaker that I mentioned is inside. So that's the whole thing. It looks very similar to my box, but again, the key is the software, which is really far and away better again than what I had produced, and I'm really quite pleased with how this came out. Dave does have a circuit board he designed for this. I just hand built this up because I had a special application with this box, but I think his board has some buttons and other niceties on it that make it quite easy to put together. This is kind of a mechanical nightmare but it works, and I managed to get everything squeezed in. So contact Dave. I'll have some contact information associated with this video that you can use to download the code and contact Dave if you've got some questions. That's about it. Thanks again, Dave. Nice job.